As per this question, a photon emitted during de-excitation of electron from state n to the first excited state in a hydrogen atom irradiates a metallic cathode of work function 2 electron volt in a photocell with stopping potential 0.55 volt. Obtain the value of quantum number of the state n. This question combines photoelectric emission and the frequency of radiation emitted when electron de-excites from higher level to lower level of an atom. It's a question combining de-excitation of electron in atoms and photoelectric effect. If you draw a pictorial representation of the process, the level n, energy En, the electron indicated as a black dot de-excite to first excited state. First excited state means n equal to 2. So n equal to 2, the energy can be calculated as E2 equal to En equal to minus 13.6 electron volt by n square. When n equal to 2, we'll get minus 13.6 by 4, which is minus 3.4 electron. The electron de-excite from a level n, we don't know the energy and the level, but it is reaching a level which is n equal to 2 and the energy is minus 3.4. So this difference in energy, h nu, is used to push the electron out. The electron is stopped by a potential of 0.55 volt. We have a relation for kinetic energy maximum. Kmax in photoelectric emission is EV0, 0.55 times of E, so 0.55 electron volt is the Kmax. So we got the Kmax for this particular electron released. Now if we apply the Bose postulate, third postulate, this is a relation connecting E initial and E final. E initial minus E final equal to x nu. In this particular case, E initial is En, E final is E2, which is minus 3.4, x nu we don't know, so we are substituting the rest. Now substituting the values, En we don't know, E2 we know minus 3.4, so even minus En minus 3.4 equal to x nu or xs. This is equation number 1 from Bose postulate. Now applying photoelectric equation, we have Kmax equal to h nu minus work function. Kmax already we have 0.55 electron volt. H nu we don't know. Work function is given in the question 2 electron volt. So maybe substitute that later, or you can substitute after substituting this value in substituting 1 into. Using 1 into, instead of h nu you can substitute En plus 3.4. Kmax you can substitute 0.55 electron volt, work function you can be 2 electron volt. So Kmax is 0.55, h nu is En plus 3.4, h nu is En plus 3.4, work function minus 2 electron volt. From this you can get En everything you got left, 0.55 electron volt minus 3.4 plus 2 electron volt. If you add all this together, so 2.55 plus minus 3.4 gets 0.85 electron volt. If you learn the hydrogen atom energy level, E1 is minus 13.6, E2 is minus 3.4, E3 is minus 1.5, D4 is minus 0.85, that means n equal to 4. Or if you want to do the calculation with steps, you already have the formula En equal to minus 13.6 electron volt by n square. Here we have En value, we want to find n, take n square left, En right. N square equal to minus 13.6 electron volt minus 0.85. So this is coming to be 4. Or if you want to get the value, divide and it comes at 16.19 approximately. If you round up the nearest single digit, 16. So root of This thing will be 4. The level from which electron started de-exciting is n equal to 4. Hope this answer is clear to you.